All right, so I'm just going to introduce you to the idea of set notation in particular when it comes to Venn diagrams. Now, the number one example I always use when I'm going through Venn diagrams is, you can imagine that I've surveyed here 10 people, all right? And I've asked, of those 10 people, who liked apples? So you can see that there's in total actually 4 people like apples. How many people like bananas? So that's B, and you can see there 5 people in total like bananas. And there's 2 people that said they like neither apples or bananas, okay? So from those 10, 3 like apples only, 1 like apples and bananas, 4 bananas only, 2 neither. Now, this part of the Venn diagram, where the 2 circles cross over, is called our intersection, okay? And it is represented, so if we're saying, we're talking about the intersection, this is the notation for it, but that would be, I guess the description is A and B. So you like apples and bananas. So when you see that N looking shape, think of the word and, all right? This is the union, okay, that's colored in red there. It's every section inside the Venn diagram. So how many people like apples or bananas? It was the 3 plus 1 plus 4. So if I randomly chose someone out of those 10 people, what's the probability that they would like apples or bananas? Well, it would be 8 out of 10, okay, because there's 8 people inside the union, and that's the notation, A, U, B. We say A or B, all right? This is where it gets tricky though. This little apostrophe, it means complement, which basically, to simplify, it means not, all right? So A and not B. So we're basically talking about, as I put here, A only, all right? And similarly, not A and B is just B only, all right? Okay, so people that like bananas only, but not the one that also likes apples. And then this is the trickier part, all right? So not A or B, okay, or not A union B, is basically talking about everything except A, and vice versa. A union not B is talking about everything except B, all right? So if you get stuck, if there is a question that asks about probability and it uses one of these notations, refer back to this diagram, this picture, which is in your booklet, and you'll obviously, hopefully then work out what section of the Venn diagram or sections of the Venn diagram they're talking about. Now, all that information is just shown sort of here as well. So we've already gone through that the middle here is the intersection, A and B. This is A and not B, so A only, not A and B, so B only, and not A and not B on the outside. All right. So a two-way table can also be drawn from a Venn diagram. This is a two-way table here. But rather than having 2 circles that overlap, we have obviously columns and rows that overlap, all right? So this column here shows the people that like apples. This row here shows the people that like bananas. And where that column and that row overlap here is obviously the intersection, right? The one person that likes apples and bananas. So this would then be people that like apples, but not bananas, the 3, or apples only. This 4 here would be people that like bananas, but not apples, right? So bananas only, yeah? And this 2, people that don't like bananas, don't like apples, the number that's on the outside. The Venn diagram also then shows us totals. So this 5 comes from the total number of people that like bananas. It's the 4 that like bananas only, plus the one that also likes apples. Same with the column here. 4 comes from the 3 plus the 1, the total number of people that like apples, right? And the total is obviously 10 because there was 10 people in that survey, all right? So let's look at some examples, starting with listing sets. This is a less common type of question, but it's still important to understand. So it says, consider the events A and B that involve numbers taken from the first 10 positive numbers or integers. So set A has, or the list for set A is 1, 2, 3, 4, 5, 6. And the list for set B is 1, 3, 7, and 8. Now, I'm going to put those numbers onto the Venn diagram. There's going to be 10 numbers in total because it's talking about the first 10 numbers. But what section do I fill out first? I fill out the intersection. So always go to the intersection first, which means I need to find numbers that appear in both set A and B. What are those numbers? Obviously 1 and 3 appear in both sets. So they're the numbers I put in the intersection, 1 and 3. The remaining numbers here, 2, 4, 5, and 6 are in set A only, and the remaining numbers here are in set B only. I should label these circles, sorry, A and B. And the two numbers that are missing are 9 and 10, because we're talking about the first 10 positive integers, okay? So that's how you would list sets in a Venn diagram. More commonly, there's just one number inside a Venn diagram, like we saw here. Sometimes you are asked to list sets. Now, based on that, it says list the following sets, A and B. We're talking about here, with this notation, the intersection. So for that, it's just 1 and 3. A or B, so in the union, so in either circle A or B, including the intersection, it's the first 8 numbers. All right, so 1, 2, 3, 4, 5, 6, 7, 6, 7, and 8. All right. Then it asks, if you randomly chose one number from the first 10 numbers, what is the probability that that number would be from set A? How many numbers are in set A? In total, there are 6 in set A over the total 10 that appear on this Venn diagram, okay? And you can then simplify that if you're not good at simplifying these fractions, because there'll be lots of fractions here, you'll see, so don't get overwhelmed. You can just put that in your calculator and it'll simplify it for you if you press equals. But yeah, 6 over 10 is the same as 3 over 5, obviously. What's the probability that if I chose a number from the first 10 numbers that it would be in the intersection of A and B? Okay, there are 2 numbers in the intersection, so 2 over 10, or 1 over 5. What is the probability it would be in the union? So anywhere inside the 2 circles. There are 8 numbers inside the 2 circles, so 8 over 10, or 4 over 5. Okay? So that's how we determine probabilities from, Venn diagrams when there's, multiple values inside the circles. Like I said, more commonly, second example, there will just be one number inside that Venn diagram. So, this example says, from a class of 30 students, 12 enjoy cricket, 14 enjoy netball, 6 enjoy both cricket and netball. So the number I want to put in first is the number in the intersection, which is 6. 6 enjoy cricket and netball, okay? From enjoy cricket, so this left-hand circle, I've already put 6 of them into the intersection. This is the biggest mistake people make. They put the 12 here, but that tells me 18 people like cricket, but there was only 12 that like cricket. So this number here should be 6 to give you the total 12, okay? For netball, in total, there were 14. So this number that goes here, obviously will be the number that bridges or adds to give me 14, all right? So 8, yeah? And then because there were 30 kids in the class, all right, the number on the outside is the leftovers. So 6 plus 8 gives me 20, which means 10 don't like cricket and don't like netball, all right? Now, I want to show you the difference between state the number and the probability. When it says state the number of students who enjoy netball only, you don't need to write that as a fraction. It's just say, what is the number of people that like netball only? So what's the set notation for netball only, do you think? Does anybody remember? It's not cricket and netball, all right? So we're looking there just at netball only, 8 over 30, which can be simplified to 4 over 15. I was showing you the probability. It's the number. So here I'm just putting the number. It's 8. All right. What is the number of people that like netball only? Here, when I ask for a number, just give a number, not a fraction. Neither cricket nor netball. So what's the number of people that don't like cricket and don't like netball? 10. Number on the outside. Now it's asking for probability. Now I would write a fraction. So what's the probability that someone randomly chosen from that class likes netball? Okay, there is 14 people in the class that like netball. Over 30 in total, which simplifies to 7 over 15. What about netball only? Okay, we did the set notation for that there already. Probability that not cricket and netball is 8 on 30, or I did that before, 4 over 15. What's the probability they like both cricket and netball? So what section of the Venn diagram am I talking about here? I'm talking about the intersection. So probability they like cricket and netball. Okay, the and there is 6 over 30 or 3 over 15, which simplifies to 1 over 5 also. All right, so that's it from the 2 Venn diagram examples. I'm going to do one more example, which is looking at a Venn diagram. It gives us a Venn diagram. It wants us to put it into a table. All right, so set up your columns for A, not A, your rows for B and not B. And this is the intersection where the column and the row for A and B meet. That's the number from the intersection in our Venn diagram, which is 1. So people that like apples in total were 3, which means 1 plus what number gives me 3? It's the 2 that like apples and not bananas. Okay? People that like bananas and not apples, or bananas only, 6. Okay, and how many people like bananas in total from this? 7. Okay, the 1 plus the 6 gives me the 7. Now this number here is the number of people that don't like apples and don't like bananas. So that's the number on the outside there, 3. Okay, and then I'm just adding up the columns here. So 6 plus 3 is 9. That's the total number of people in the Venn diagram that don't like apples, by the way. 2 plus 3 is 5. That's the total number of people in the Venn diagram that don't like bananas. And these 2 values should add up to the same as these 2 values, which they do. So there were 12 people in total on that Venn diagram, okay? So 2-way tables are good because they show you a little bit more information as well, all right? I'll quickly run through these. From that, just find the number of people that like apples and bananas. So that's that one there, 1. The number of people that don't like apples and bananas, or bananas only, that's 6. Okay, so that's that one there. Find the number of people that like apples and not bananas, or apples only, that's that one there, 2. The number of people that don't like apples and don't like bananas, that's 3. Number there. Number of people that like apples. Okay, I have to add these 2 and 1, or it gives me the total there, 3. Total that don't like bananas is 5. And the total in the union, that's not given on the intersection. On the 2-way table, but it is 2 plus 1 plus 6, which gives me the 9. All right, so 9 people like either apples or bananas. All right, based on that as well, what is the probability that if you chose someone randomly from that group of 12 students or people, that they would like apples and bananas? 1 over 12. What is the probability that they would not like apples? 9 on 12, or 3/4. What is the probability they would like apples and not bananas, or apples only? Okay, so apples and not bananas here, it's 2 over 12, or 1 on 6 to simplify. All right, so that's That's a lot of information to take in. But yeah, like I said, if you get stuck, go back to this picture here about what section of the Venn diagram represents the different notations. One last quick thing is the idea of mutually exclusive events. If two events are mutually exclusive, they have nothing in common. So for example, if we were surveying people at this school, you'd either be a teacher or a student, right? You couldn't be a teacher and a student. I mean, yes, you can like apples and bananas, but based on that example, so that they're not mutually exclusive, but something that is mutually exclusive is something that has nothing in common, so there'll be no overlap of those Venn diagrams. So that's an example I use regularly, teachers and students. The N, think of the word and. The U means union, but think of the word or. This symbol here, the zero with a line through it, means a null or empty set. So if I did survey people and there was no teachers at school, but 1,700 students at school, then T is an empty or null set. Okay, it means there's no data in that part of the Venn diagram or two-way table, for example. All right, guys, make sense? All right. Thanks for watching, like and subscribe.